Alright, in this video I want to go over the electron configuration questions that are on the CBA review. We didn't get to talk about electron configurations a whole lot, and I think a lot of you are still not quite sure what to do with it. So let's look at it. Let's get out your periodic table and let's go ahead and look at these examples, okay? So I want you to go ahead and grab your periodic table first, and let's go ahead and review how to just figure out where the S and the P and the D and the F are on the periodic table. Okay, so let's look at this periodic table. Remember that the first two rows, okay, I'm just going to draw on mine. The first two rows are the S block, or the first two columns are the S block, okay, and the last 6 columns are the P block, with the exception of this guy. Okay, so I'm going to switch over to a marker. I'm going to draw it out. This guy is in the S block. Alright, so it is actually supposed to be all the way over here. Alright, right on top of BE. Okay, now the people in the middle, or the elements that are in the middle, okay, these guys right over here, this makes up the D block, and the last two rows that are on the bottom, this is our F block. Okay, alright, now there are two forms of the electron configuration. So the first form that you have to know is the arrow form. Alright, and that is probably going to be a couple questions on the CBA on the arrow form. Okay, now with O, what you have to think about is O has 8 electrons. Now how do I know? Because I looked it up on the periodic table. Okay, O has an atomic number 8, so it has 8 electrons. Alright, so that means I need to show in my electron configuration where all 8 of the electrons are. Okay, so the way that I'm going to do this is go through the periodic table starting from atomic number 1 all the way to atomic number 8. Okay, so what I'm going to do is start from atomic number 1. Here it is, and this is in the S block and in the first row of the S block. So this is 1s. Okay, and in atomic number 2, we establish that this is in the S block and it is also the first row, so it is 1s. Okay, so I have 2 electrons in 1s. Next, atomic number 3 is in the S block and it is in the second row, so it is 2s. Okay, and BE, atomic number 4, is also in the S block and it is also in the second row, so it is 2s. Alright, so I have now established that the first 2 electrons are in 1s and the second 2 electrons, 3 and 4, are in 2s. Okay, that's what this means. Next, I'm going to go over to atomic number 5. Atomic number 5 is in the P block. Now, if you remember, there are 3 p orbitals and they go like this. It's px, py, pz, and then px, py, and pz again. Okay, so in this case, I have this guy in, or number 5 in px, and this is the second row, so it is 2px. Okay, and then this guy, atomic number 6, is 2py, because it's in the second row, it is py. And atomic number 7 is pz, and it's in the second row, so it's 2pz. So now what I've established is there's 1 electron in 2px, there's 1 electron in 2py, and there's 1 electron in 2pz. And finally, atomic number 8, that's where I want, right? Because my problem was oxygen. So this one is px, and it is 2px because it's in the second row. So what I have established based on the periodic table is that 2 of the electrons, the first 2 electrons for oxygen, are in 1s. The second two electrons, number 3 and number 4, are in 2s. There is number 5 is in 2px, number 6 is in 2py, number 7 is in 2pz, and number 8 is in 2px. Okay, and then now all we have to do with the arrows is just symbolize all those electrons. Okay, so we use up and down arrows. The first two we established were in 1s. So it is 1s, and the first one is up, and the second one is down. Alright? All the arrows are telling you are the electrons. Where are the electrons? Okay, and we said that number 3 and number 4 were in 2s. So it's up and down in 2s. Number 5 we established was in 2px. Number 6 was in 2py. And number 7 was in 2pz. And then number 8 was in 2px. Okay, so this is how we write it out in what's called the arrow form. All the arrows are telling you is they are the electrons. They are symbolizing the electrons. Okay, so oxygen had 8 electrons. We should have 8 arrows. 1, 2, 3, 4, 5, 6, 7, 8. Yes, we do have 8 arrows. Okay, let's look at B, Si. I'm going to go back to my periodic table and check out where Si is. Si is number 14, which means it has 14 electrons. And since it has 14 electrons, then there must be 14 arrows. Okay, now how do I figure out where every one of these electrons are? Well, I have to start from atomic number 1, which is symbolizing electron number 1, and go all the way to atomic number 14. Okay, so atomic number 1, which is electron number 1, is in the s block and in the first row, so it's 1s. Atomic number 2 is in the s block and it's in the first row, so it's 1s. Atomic number 3 is in the s block in the second row, so it's 2s. Atomic number 4 is in the s block in the second row, so it's 2s. Atomic number 5 is px and it's in the second row, so it's 2px. Atomic number 6 is 2py. Atomic number 7 is 2pz. Atomic number 8 is 2px. Atomic number 9 is 2py. And atomic number 10 is 2pz. Okay? Now, why do we do this XYZ, XYZ thing? It's because of Hund's rule. If you remember Hund's rule, it said that I have to give each of these orbitals one electron first before I give them the second one. So I gave px 1, py 1, and pz 1 electron. Then I can go back to px and say you get a second electron. Okay, so px gets a second one, and py gets a second one, and pz gets a second one. Alright, now let's continue. Okay, I am at atomic number 10. Let's go on to atomic number 11. Here is electron number 11, and it is in the s block and it's in the third row, so it's 3s. Atomic number 12 is in the s block and in the third row, so it's 3s. Atomic number 13 is in px and it is the third row, so it's 3px. And finally, atomic number 14 is py and it's atomic number, or the row number 3, so it's 3py. Okay, so now we have established this on our periodic table. Let's put it into symbols. Okay, the first 2 electrons are in 1s, up and down, 2 electrons. Okay, the next 2, 3 and 4, are in 2s, up and down. Atomic number 5, where electron number 5 was in 2px. Electron number 6 was in 2py. Electron number 7 was in 2pz. Okay? Notice that I gave each of them one first. Then I'm going to go back and give them a second one. Okay? So electron number 8 goes to px. Electron number 9 goes to py. And electron number 10 goes to pz. Okay? Electron number 11 and 12 are both in 3s. Then we say electron number 13 was in 3px, and electron number 14 was in 3py. Okay, count up all the arrows, there should be 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Alright, and the last one for the arrow form on the review is F. Okay, if you look at F on the periodic table, it is atomic number 9, so it has 9 electrons. Okay, and all this means is I have to go from atomic number 1 all the way to atomic number 9 and write out all of its electron configurations. Okay, so starting with atomic number 1, that is our electron number 1. It's in the s block and in the first row, so it's 1s. Atomic number 2 is in the s block and it is in the first row, so it's 1s. Atomic number 3 is in the s block in the second row, so it's 2s. Atomic number 4 is in the s block and it is the second row, so it's 2s. Atomic number 5 is in px and it is the second row, so it's 2px. Atomic number 6 is 2py. Atomic number 7 is 2pz. Atomic number 8 is 2px. Atomic number 9 is 2py. And that will get me to fluorine. So I'm going to stop right there and write these down in symbols. Okay, so here we are. 1s, 2 of them. Number 3 and number 4 and 2s, so 2 arrows. Okay, and then number 5 is in 2px, up. Number 6 is in 2py, up. And number 7 is in 2pz, up. Okay, and then number 8, we are going to go back to px, that's the down. And number 9 is 2py, down. Okay, so if you count up the arrows, 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go, 9 arrows, 9 electrons. Okay, let's go on to number 51. For number 51, we have superscripts, okay? So instead of arrows, we're just going to write down how many electrons there are in the orbital as a superscript. Remember, a superscript goes on top of the symbol, okay? So it's just a little number, either 1 or 2, on the top of the symbol for the orbital. Okay, and now we can use shortcuts. So there are 2 shortcuts. The first shortcut is you can go back to the noble gas before that atom that you're dealing with, okay, and put that in a symbol. And the second one is you can either use P6, D10, or F14 if they are filled up. So let's look at how this works. Okay, so A, SB. So the first thing you want to do is find SB. SB is right over here. Okay, here it is, number 51. Alright, as you can see, if I am going to go from number 1 all the way to number 51, this electron configuration will take half a page. So I am not going to do it the long way. I am going to go ahead and use a shortcut. Okay, so the way that you go with the shortcut is you are going to back up from number 51 to the noble gas before it. So I'm going to go ahead and go backwards and backwards and backwards. Okay, I get to atomic number 37 and I'm going to go to the row before it, number 36. Number 36 is a noble gas. So I am going to write down KR in a bracket, and I know that that's number 36. Okay? Alright, then starting from number 37, then I can use the regular electron configurations. Okay, write down the last row. So number 37 is in the S block and it is 5s because it's in the 5th row. Okay, number 38 is in the S block and it is 5s because it's in the 5th row. So how many electrons do I have in the S block? or in 5s? I have 2, so I'm going to write down 5s2. Okay? I'm going to continue. Number 39, all the way through number 48 are in the D block. And this is actually 4D. Okay, the D block is one row behind the others. So 4D, and there are 10 of them if you count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to write 4D10. That will save me a lot of space. Okay, 4D10. Alright, and then finally, I'm going to go ahead and get to the rest of it, up to SB. Okay, so number 49 is in PX, and it's the 5th row, so it's 5PX. SN is in 5PY, and SB is in 5PZ. Okay, so it looks like I have 1 in 5PX, 1 in 5PY, and 1 in 5PZ. So the way I'm going to write this in superscript is 5PX 1, 5PY 1, 5PZ 1. And that is it. Now, if you are going to check your answer, all you need to do is add up the little superscripts. Okay? And remember that we said that SB has 51 electrons. If you add these up, it should equal to 51. So 36 plus 2 is 38, plus 10 is 48, 49, 50, 51. Yep, it has 51 electrons, and they add up to 51. Okay? Alright, let's look at B, PT. PT is number 78, right over here. Okay, we are going to back up. Again, back up to the noble gas before it. This is XE. So XE is number 54. Okay? And so starting with number 55, I'm going to write out the whole thing. Okay? 55 and 56 are both in 6S. It's the 6th row in the S block. So there are 2 of them. I'm going to write down 6S2. Right, the next thing. We ended at 56, but where is 57? 57 is down here. Okay, so I have to go in order of the atomic number. 57 all the way through 70 are in the F block. So what I can do is just write 4F. Now remember, the F block is 2 rows behind everyone else, so it is 4F. Okay? Alright, so 57 all the way to 70 are 14 electrons. Okay, you can count the boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I'm going to write 4F14. Okay, then here's 70. I'm going to go back to 71 now. 71 is in 5D, and it's 5D1. Okay, 72 is 5D2. 73 is 5D3. 74 is 5D4. 75 is 5D5. 76 is 5D1 again. Okay, remember that there are 5D orbitals. 77 is 5D2. And PT, 78, is 5D3. Okay, so if you check out these guys in the D's, alright, what you will notice is I actually have 2 electrons in 5D1, this one and this one. Okay, I have 2 in 5D2, this one and this one, and I have 2 in 5D3. Okay, but I only have 1 in 5D4 and 1 in 5D5. So the way that we will write this is 5D1, 2, because we had 2 electrons in 5D1. 5D2, 2 electrons in 5D2. 5D3, 2, because there are 2 electrons in 5D3. Okay, and then 5D4, 1, because there's only 1 electron in 5D4, and 5D5, 1, because there's only 1 electron in 5D5. Okay, Now we said platinum, PT, has 78 electrons. So if we add up these superscripts, we should have 78. 54 plus 2 is 56. 56 plus 14 is 70. 72, 74, 76, 77, 78. So they do add up to 78, so that is correct. Okay? Alright, moving on to Pu. You look up Pu on the periodic table, it is number 94. Okay, so it will have 94 electrons. I'm going to write this out here to remind myself later on. Okay, so 94 electrons. Okay, I am going to have to back up to the noble gas before it. So I'm going to count backwards. 94 up to 89, and 88 is all the way up here. Okay, 88 is up here. And then 87, and then 86 happens to be a noble gas. So I'm going to write number 86, Rn, into the bracket. Okay, alright, number 86 is Rn, so now all I have to do is start at 87. 87 and 88 are both in the S block in the 7th row, so it's 7S. Okay, so there are two of them, so it's 7S2. Alright, that was number 88. Now 89 is down here. And remember, the F block starts 2 rows behind, so instead of 7, this will be 5. So it's 5F. Okay, and 5F. We are going to go to Pu, so that's not the entire row. I cannot just write 5F14. I have to actually break them down. Okay, so it's 5F1, 5F2, 5F3, 5F4, 5F5, and 5F6. Okay, and that's it. Remember, there are 7 F orbitals. We didn't even get to 7. So it'll be 1, 2, 3, 4, 5, 6, and there's 1 electron in each of them. So the way that we're going to write this is 5F11, 1 electron in 5F1, 5F21, 1 electron in 5F2, 5F31, 5F41, 5F51, and 5F61. Okay, all of these symbols mean is that there's 1 electron in each of these F orbitals. Okay? Alright, again, we're going to add the superscripts, and they should equal 94. 86 plus 2 is 88, 89, 90, 91, 92, 93, 94. So yes, that is 94 electrons, and the superscripts add up to 94. Okay, and finally with D, ZR. ZR is number 40, okay, right over here. So we are going to go backwards to number 36, KR. So I'm going to put KR into the bracket, number 36, and I'm going to write out over here just a reminder that ZR has 40 electrons, okay? Alright, so I'm starting with number 37. Number 37 is 5S, and number 38 is 5S, okay? So that's 5S2. Alright, and then I have to get to number 40. So it's 41 and 42. So there's 1 in each of those. 41, 1. 42, 1. Okay, if you add these up, that should equal 40. And so 36 plus 2 is 38, 39, and 40. So yep, that equals 40. 40 electrons. Superscripts add up to 40. Okay, so I hope that helps you a little bit with the electron configurations. If you need more help, make sure you come to tutorials, please, before school on Monday.